Hello everyone, welcome back to this online class. Today we are going to look at numerical solution of ODEs, and we are going to look at boundary value problems, a case where we have mixed boundary conditions, that is a combination of both Dirichlet and Neumann boundary conditions. So we are going to look at finite difference method. Now we have this question. We are asked to use finite difference method to solve the boundary value problem given by d squared y over dx squared is equals to xy, subject to the boundary conditions that y of 0 plus y prime of 0 is equals to 1, and y of 1 is equals to 1. Take a step size of h is equals to 1 over 3 and compute the values of y of 0, y of 1 over 3, and y of 2 over 3, correct to 5 decimal places. So first of all, let's analyze this problem. Look at our boundary conditions. They are defined at x is equals to 0. That will be our x naught. And the other one is at x is equals to 1. That is our xn. I don't know n, but based on the step size, we'll know what n means. So let's draw this kind of a line to illustrate what we mean by x naught, xn, and the step size of 1 over 3. So if I have this, we have 0, x is ranging from 0 up to 1. So we have the condition at the starting point and at the end point. So that our step size is 1 over 3. So that means I'll have 1 over 3 here. Continue adding 1 over 3, you'll get to 2 over 3. Now this is x naught, x1, x2, x3. The spacing between them is uniform. That is 1 over 3, which we're calling h, the step size. Now, do we know the value of y when x is equals to 0? We don't know, but we know the combination of y of 0 plus y prime of 0 is 1, but we don't know y of 0. So this is not known. Do we know the value of y when x is 1 over 3? We don't know. Similarly, we don't know the value of y when x is 2 over 3, but we know the value of y when x is 1. The result here was 1. This is 1. So we are going to say that this is y naught, y1, y2. This is y3. So it means the one I was calling xn, instead of n here, you should write x3. So the unknowns are y naught, y1, and y2. Remember that when we write y naught, it is the same as y at x naught, and our x naught is 0. So this is y of 0. We don't know this, we'll work it out. When we write y1, it is y at x1, which is y when x is 1 over 3. We will also work it out. And lastly, y2 is y at x2, which is the same as y when x is 2 over 3. We also don't know this, we will work it out. So we have 3 unknowns, and the unknowns are when we have the subscript 0, 1, and 2. Now, let me take you back to the ODE. Our ODE is d squared y over dx squared is equals to xy. It can be written in prime notation as y double prime of x, remember is a function of x, is equals to x times y, which is also a function of x. The next thing is to evaluate the ODE. The ODE at x is equals to xi to get, so where there is x, I'm going to put xi, so we'll get y double prime of xi is equals to xi times y of xi. take note that when we write y of xi, this is the same as writing y subscript I. When I write y double prime of xi, this is the same as yi double prime. So using those notations, this equation can now be written as, we can say, or yi double prime is equals to xi times yi. So use central difference scheme to approximate the derivatives. So you write use central difference scheme to approximate yi prime and yi double prime. Remember from our central difference scheme that when we write yi prime is the same as yi plus 1 minus yi minus 1 over 2h, and the second derivative yi double prime is the same as yi plus 1 minus 2yi plus yi minus 1, everything over h squared. Now, let's substitute them back into our ODE. This equation can now be written as, the one that I'm bracketing, can now be written as, you now get rid of the derivatives. So therefore, we have a simple equation, let me call it equation star. Equation star becomes, it is now yi plus 1 minus 2yi plus yi minus 1 over h squared is equals to xi yi. Cross multiply by h squared, so write or yi plus 1 minus 2yi plus yi minus 1 is equals to h squared xi yi. And then you collect like terms. Let's start with yi minus 1 or yi minus 1. Go to yi. I'm done with this. Now yi, of course, I'll check this to the left-hand side. So what I'll have is the negative 2 and also negative h squared xi. So this you combine with this. That will give us negative 2 plus h squared xi yi. Then lastly we have plus yi plus 1. That should give us 0 on the right hand side. So what we have here is the finite difference scheme that will help us calculate the values of y0, y1, and y2. So this is, you can comment on it and write, this is the finite difference scheme. FD means finite difference, and this scheme is valid for I is equals to 0, 1, and 2. As you can see, our unknowns, we said the unknowns from here, from this diagram, that y0, y1, and y2, we don't know them. So when I is 0, when I is 1, and when I is 2. That means we are going to iterate from I0, 1, and 2. Let's start with the first iteration. So you can write put I is equals to 0. When I is equals to 0, what are we going to get? It will be y subscript negative 1 minus 2. Remember, we know the value of h. I could replace h instead of h squared, and we know h to be 1/3. So you can just write here, put h is equals to 1/3, so that we just replace it here. So let me, instead of writing h squared, that should be 1/9. So right here, 1/9. That is h squared. We don't have any other h. So that is 2 plus 1/9 xi. And remember, I is 0. So instead of xi, that will be x naught, y naught, plus y1 is equals to 0. What is the value of x naught? So you can write put x naught. Our x naught was equals to 0. Let me take you back to the diagram. This is x naught, which is 0. So we replace it. When you substitute that, you're going to get right here, or y negative 1 minus 2 y naught plus y1 is equals to 0. But you see, our unknowns are y naught, y1, and y2. So I have to know what is this one, y raised to y subscript negative 1. What is it in terms of y naught, y1, and y2? So you express this, express it in terms of y naught, y1, and y2, because those are the unknowns. So the question is, how do we get it? We will go back to the boundary condition. So take note that our boundary condition at the lower end, was y of 0 plus y prime of 0 is equals to 1. And the 0 here is x naught. So this means that y of x naught plus y prime of x naught is equals to 1. And we said, when we write y of x naught, that is the same as y naught plus y naught prime is equals to 0. Also, the central difference scheme for the first derivative, we said yi prime is equals to yi plus 1 minus yi minus 1, and this is over 2h. So when you evaluate when I is equals to 0, what will we get? So you write put I is equals to 0. This will give us y naught prime is equals to y1 minus y negative 1, everything over 2h. And remember, h was equals to 1/3. So from this, when you cross multiply, you are going to get y negative 1 is equals to y1 minus 2h times y naught prime. What is our h? Our h is 1/3. So this is y1 minus 2/3 y naught prime. But the question is, what is y naught prime? You can get it from here. But y naught prime is the same as negative y naught. From this equation, if I make y naught prime the subject, I get y naught prime is negative y naught. So when I replace it back here, I'll get y negative 1. So remember this was or y negative 1 is equals to this. So replace y naught prime by negative y naught. So instead of this, this is negative y naught. So you can say that therefore y negative 1 is equals to y1 minus 2 over 3 times negative y naught, which you can write as y1 plus 2 over 3 y naught, or y negative 1. So that's the expression for y subscript negative 1. It is y1 plus 2 over 3 y naught. So let me take you back to the equation where we are supposed to replace it. We'll now replace it by what we have just found. So that will be equal to before, you remember the boundary condition was 1 instead of 0. This correction here, instead of this, it is supposed to be 1. Remember, it was 1, not 0. So this is 1. So I expect this to be plus 1. There's a plus 1 which we didn't write. So instead here there's a plus 1. Also here, so let's wrap this and write plus 1. So when you do the calculation, you'll find that we have another negative 2 over 3 that I left out. So there's a minus 2 over 3. That's the correct value. I left out the 1. That's why we have that correction. So having found y negative 1 as y1 plus 2 over 3 y naught minus 2 over 3, let's now replace it back into our equation that we had here. I'll tell you how to do it. So this equation will now give us, the whole of this equation, it will now give us this. Instead of y negative 1, we'll have y1 plus 2 over 3 y naught minus 2 over 3, then minus 2y naught plus y1 is equals to 0. And if you simplify, you need to get, because we have 2 over 3 minus 2, that should be able to give you, so press that in your calculator, is like 2 over 3 minus 6 over 3, that's negative 4 over 3. So negative 4 over 3 y naught. Then those of y1, those will be 2y1, 2y1. The constant is just negative 2 over 3 you take to the right hand side, that is becomes 2 over 3. I can decide to multiply, because I can see 2 is common. Let us simplify this one so that we'll have, or multiply through by 3 over 2. That's what I'm going to do. So that should give us negative 2 y naught plus 3y1 is equals to 1. So this is the first equation. Call it 1. That is when I is equals to 0. The next iteration is when I is equals to 1. So the next we write put I is equals to 1. Remember we have used 0. So when you substitute I is equals to 1 into our finite difference scheme, what are we going to get? Let me take you back to our finite difference scheme. It was this one. Where there's I, you put 1. So we'll have y naught minus 2 plus 1 over 9 x1 times y1, then plus y2 is equals to 0. That's what I'm going to write. That y naught minus 2 plus 1 over 9 x1 y1 plus y2. That should be able to give us 0. We don't know y naught, we don't know y1 and y2, but I know x1. So you can write put x1 is equals to, if you go back to our line that we had drawn, it was 1 over 3. That is the value of x1. Let me take you back. Our x1 is 1 over 3, this one. So that's what I'm going to substitute here. So that you are going to get, that will give us or y naught minus 2 plus 1 over 9 times 1 over 3 y1 then plus y2 is equals to 0. And if you work it out, you get y naught minus 55 over 27 y1 plus y2 is equals to 0. So this is the second equation. Write Roman 2 and bracket it. And finally, the third iteration when I is equals to 2. So you write put I is equals to 2. What are we going to get? It will be y1 minus 2 plus 1 over 9 x2 times y2 plus y3 is equals to 0. And so what do we know? We know y3 and x2. First of all, put x2 is equals to 2 over 3. And I also know y3 was equals to 1. Let me take you back so that you see what you get. It was here. We are replacing x2, which is 2 over 3, and y3, which is 1. So when you do those substitutions, when you make the substitutions, this is what you're going to get. y1 minus 2 plus 1 over 9 times x2, which is 2 over 3, y2. Then plus our y3, which is 1. That should give us 0. And so if you simplify this, you need to get, you write or y1 minus 56 over 27 y2. Take 1 to the right hand side, it becomes negative 1. So this is the third equation. You write equation number 3. Bracket it. So we have 3 equations in 3 unknowns, and so you need to solve them simultaneously. So you can write solve equations 1, 2, and 3 simultaneously. to get, remember when we talk of simultaneous, you can use any method. There are quite a number of methods. There's a elimination method, substitution method, you can use matrix inversion method, you can use Cramer's rule, whichever method that is easier for you. When you solve them, you need to get your value of y1, y0, we start with y0. That should be equal to negative 0.98795. 0.98795. Our y1 should be equal to negative 0.32530. 32530. And finally, our y2 should be equal to 0.32530. So we said y0 here is the value of y when x is 0. y1 is the value of y when x is 1/3. And finally, y2 is the value of y when x is 2/3. So we have found the missing y values. So this is how to go about the Dirichlet plus Newman boundary conditions. Thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech and me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving numerical solution of boundary value problems. Bye-bye.